All right, in Unit 5, we're going to be looking at law of sines. We want to be able to use the law of sines to solve for the missing side or angle of a triangle. The triangles we're going to be looking at are oblique triangles. Those are triangles with no right angles. And so we're not going to be able to use regular sine, cosine, and tangent. Triangles can be solved if you have 3 out of the 6 parts. So what we mean by the 6 parts is the 3 angles in the triangle and the 3 sides. So we need 3 of those 6 things in there. And here's what law of sines looks like. It's right here. We're going to be taking the sine of an angle over the side opposite. So like when we talk about sine of angle capital A, that's the angle. And then little a would be the side opposite that one. Same with big B and little b, big C and little c. We're not going to be using all 3 of these at once. We would pick 2 of the 3 to use. So we might use like these 2 if that's the information that works. Or maybe we just use these 2. Or maybe we just use A and C. But we use a combination of 2 of them depending on what info we have. Let's try one out. So the first one here, we have that angle B is 35, angle C is 105. We know side little b here because it's opposite of angle B, so little b here would be 7. And we're trying to find side little c, which is opposite side C. So because we don't know anything about side A, and we could find angle A if we wanted, because remember all 3 angles in a triangle add up to 180. I think we don't need to because we're only looking to find side C here. So let's set this one up. We're going to do sine of angle B over little b because we know both of those. And then the one we want to find is C, so we're going to do sine of angle C over side C. So now let's fill in what we know. Angle B is 35, side B is 7, angle C is 105, and then the one we're trying to find here is little c, so we'll leave that as a variable. To solve this, let's cross multiply. So we're going to multiply these 2 and then multiply the other 2 as well. So we're going to end up with c times sine 35 equals 7 times sine 105. Now, I could do that at the calculator right now. I'm going to wait here because we're going to have to do one more thing. Final thing would be to divide now by sine 35. Now we can figure out approximately how big side C is. So in your calculator, make sure you're in degrees mode, and then we're going to type this one in. So you got 7 sine of 105. Make sure you close this parentheses up now, and then hit divided by the sine of 35, and this will tell us how big that side is. So it looks like it's about 11.788. So that would be the length of side C. All right, next example. Here we have side C being 340. So let's put that on our picture. We have angle A being 75, so we'll put that angle on here too. And we have angle B being 60, so we'll also fill in this one. Find what they want us to find here is what is B. So we got a good start here because we know sine of angle B, and we also want to find side B. So we for sure got to include those 2. And we know we can fill in here that angle B is going to be 60 degrees, which is the one we want to compare it to. Well, we can't use A because we don't know how big side A is, and we can't have 2 missing things in our problem. So that won't work. We do know though side C, and in this one, since it's angle side angle, we're going to have to figure out our other angle. And that's not too hard because in a triangle, remember, all our angles add up to 180. So if we add up angle A plus B plus C here, it equals 180. Angle A is 75. Angle B is 60. So we should be able to find angle C by just doing some adding and subtracting here. If we add those two angles up, that's 135 degrees. Meaning if we subtract here, that leaves 45 degrees for angle C. So now we know angle C here is 45 degrees. You can put it on the picture too here. And we have side C, which is 340. So now we got enough information here to solve for side B. So sometimes you might have to do a quick solve for an angle if you have this angle side angle situation. All right, same as last time now. Let's cross multiply here. We can multiply these two and the other two and solve here. So now we got B times sine 45 equals 340 times sine of 60. Divide by sine of 45. And we should be able to get our answer here. So that one now you can put in the calculator and we could get our answer here. So I got 340 sine 60 divided by sine 45. And looks like our approximate length there for side B is approximately 416.413. All right, next example, sketch the triangle and solve. So here they don't give us a picture. If you get one of these without the picture, do one yourself. It doesn't have to be super intense. Just make sure you get all the information on there. So I'm just going to draw a regular triangle out here. Angle A, I'm going to put here as 42. Angle B, that again doesn't matter. I'm going to put it here as 95. And it doesn't matter that our picture is not accurate as long as you get the information on there. Meaning this is going to have to be angle C then. And little c here is the one opposite, which is 125. This would be side little a and side little b. They want us to sketch this triangle and then solve it. If they say solve the triangle, that means they want us to find all the missing information. Let's start with the angle because that's probably easiest. So angle C we can find by doing just some subtraction here. So if we take 180 and minus those other two angles, we should get it. So doing a quick subtraction, that's going to tell us that angle C is 43 degrees. Okay, so we got that. Now we got two missing sides we got to find. We also have to find side A and side B. Write this on there, that's 43. Okay, so now you just got to set up your signs and see what you get. Let's do one together and then have you try one. So let's do angle A together. If we were doing A, we'd want to include angle A and side A. And then you got to include the combination we know. The only combination of angle and side we know is C right now. So let's use that one. So we got sine C and side C. Now if you fill everything in, we got 42. We're solving for side A. This is 43 degrees over 125. Now cross multiply and divide, and you should get what angle A would be here. And if you solve it out correctly, it should come out to be approximately 122.64. Let's have you guys now try and see if you can get B. So pause the video, Try it out and see what you get. All right, let's see what you got here. You want to probably use B and C as the ones because we know angle B here is 95 and we know sine or angle C is 43 and side C is that. Cross multiply and divide, you should put that now in your calculator and you should have got about 182.587 as the length for side B. Just as a check, you can when you're doing these two, remember the biggest side should be across from the biggest angle. Our biggest angle here is angle B, so that should be the largest side, and it is. 182 is the biggest length we got. The smallest side should be across from the smallest angle. Um, Angle A is our smallest angle, and you can see side C is smaller than side C, so it looks like we did a pretty good job there. All right, last case of these is if you have side-side angle. So if you have side-side angle and one of your angles is less than 90, then you need to check the angle and its supplement because there might be two possible angles that we could use when doing this. So let's look at example 4. We're going to sketch this out. We got a triangle, call it ABC here. Again, it doesn't matter that your picture's that great, just need information. You got 50 degrees here. Side across is 10. We got side B across from angle B needs to be 8. Find the measures of the missing angles. So we need to find out what's angle B and angle C. In this case, angle B would have to be found first because we don't know anything about side C. So we'll start with using angle A, which is 50, side A, which is 10. Angle B we're going to find, side B here is 8. So let's do our cross multiplying these two and these two. So now we got 10 times sine of angle B equals 8 times sine of 50. We're going to divide by 10 here. Okay, so now we got sine of B being equal to this. And then at this point, to solve for this, we're going to have to solve for the angle by bringing sine over to the other side. Recall though, when you bring sine over to the other side, it's not going to be sine anymore, it's going to be sine inverse. So we want to do inverse sine of 8 sine 50 over 10. So that's what we're going to put in our calculator now to find out what that angle measure is going to be. So you're going to start by doing inverse sine. Then we got 8 sine of 50, close that parentheses up for the angle of sine 50, and then divided by 10. And it tells us that the angle is going to be about 37.795. Okay, so that's angle B. So what we got to look at now is what would angle C be? And we also have to check, is there another option for angle B? Meaning that its supplement, the angle that adds up to 180 with it, could that be a possible angle too? So let's first find angle C on this case because this case should work. If we find angle C should now be 180 minus the 50 degrees minus 37.795. We can put that in our calculator. Let's see what we get here. So we got 180 minus 50 minus, and I'll just type it in 37. So it looks like angle C comes out here to be 92.205. So there's angle C for this one. There's angle B. We already got angle A. The other one we need to check, could the supplement work? The supplement to angle B would be the angle that if we subtract from 180 would work. So if we take 180 minus what we got for angle B, this could be a potential option also for B here. So let's check what this comes out to be. So if we did 180 we get this. So another possible option might be 142.205. Could that also be angle B as well? Well, let's check that one. We'd have to figure out also what angle C would be. So if we did 180 minus 50 minus 42.205, that would be what angle C is. But you can see this one's not going to work because this is going to end up being a negative angle. But we don't have, just adding these two up is already over 180. So this case doesn't work in this particular problem. Sometimes it will, sometimes it won't. I'm going to use this GeoGebra link to kind of show you guys why this one doesn't work. And then I'll show you why it does work on another one. So if we put this triangle in, here's a picture on GeoGebra of this. We got angle A here I put in as 50, what we had. Side A was 10, side B was 8. And you can see only one triangle is possible there in blue. The other possible triangle would be this one out here, but that's not possible because our angle would extend too far and it doesn't work. So only one possible triangle in this case. Sometimes you can have more than one depending on what you put in, and I think we'll see that in our last example here. So our last one says sketch a triangle and then solve it. So let's again draw this out. So I got A, B, and C here. This is 43.1. And then side B across from angle B here is 248.6. We want to find all the missing stuff. Let's again find angle B first here. So if we use angle A and side A, and we don't know angle B right now, but we can find it, and we know side B is this. Let's do our cross multiplying again here. So if we cross multiply, we get 186.2 times sine of angle B equals this. We're going to have to divide here by 186.2. And then that leaves us with sine of angle B being equal to all this stuff. Last thing we need to do now, just like we did in the previous problem, is do inverse sine now. So angle B is going to be inverse sine of all this stuff. So let's put that in the calculator and see what we get. So if we put that one in, do an inverse sine of 248.6 times sine of 43.1. Close that parentheses up always and then divide it by our other side here. And it looks like our possible angle here for B ends up being 65.819. All right, so let's, we know, it looks like this one's gonna work. So let's do our last thing now and let's find angle C. So angle C should be 180 minus our angle A, which was this, minus our angle B that we just found. If we put these ones in our calculator, we can get this angle C. And it looks like the possible angle there is angle C is going to come out to be about 71.081. Okay, so we got all three angles. Now, there is one last thing if we're going to solve this out. We got to find side C. We could do that now because we got enough information here, so you can do um, sine of angle. We can use just our angle A combination that we had with side A being 186.2. And now we want to include angle C here, the one we just found, over side C, and then we can solve for that by cross multiplying. I'll let you, if you want to finish that part up, do that. But this last part now, we got to check, is there another possible angle here? So our other possible side B, or sorry, angle B, would be the supplement. So we can take 180 minus the angle we got here for B, which is 65.819, and see what we get. So if we put that in the calculator, another possibility here for B could be 114.181 degrees. Does this one work? Let's try to solve for C now. So this C on this one would be 180 minus 43.1 minus this angle B we just came up with, what, 114. And this one looks like it will work. There's two possible angle B's that we can have with two possible angle C's, because when we subtract that, that will work out. We got enough angle to work with here when doing this. So if we do 180 minus this angle we just came up with, minus 43.1, it is possible to have another triangle here. So the other triangle could have an angle of 22.719. I'm going to show you this one with GeoGebra too. Reason this one works is that we have enough angle to work out. So I used the about 43 degrees like we had in the problem. I did just proportionally take down the length of the sides here so it works in GeoGebra, but you can see there's two possible triangles that can work with this depending on what side or angle B and angle C end up being. So the one case we had where angle B wasn't so big was this one. That was the first one we did where angle B came out to be about 65 degrees here. And then angle C up top came out to be about 71. So that was one triangle. The other possible triangle we could have with the same angle here for A, the same length for side B, and the same length for side, this is side A, the moving one here is right there. And that one came out where B was quite a big angle. The supplement angle was 114 and obtuse angle, and then C came out to be a smaller angle of 22. So there's two possible triangles. So that's why you got to check when you're solving for angle with sine, law of sines, is because sometimes there might be a second triangle that can work. And so there's our second combination of angles that we could have. And then again, if they're asking to solve the triangle, then find that third side here. So we could do our angle A combination here with our new angle C, and we could solve for that sine C by cross multiplying angle. Side C should come out to be smaller on this one than it would on the other one. So that is the last case. So when you're doing angles, just make sure you check for both possible cases.